Okay, so let's talk about the magnetic field on Mars. Mars does not appear to have an overall magnetic field of its own, but there are places or regions that magnetic fields are thought to be, or deposits that were magnetized during an earlier time when the planet did have a magnetic field. So it had a magnetic field, but somehow now the overall magnetic field on Mars created by itself is gone. All right, this is a very interesting slide that I will spend a little bit time on this slide. So it's about the water phases, right? So water phases mean water can exist at, have three phases. So solid, liquid, and vapor. So here, this graph is really interesting. It's y-axis, the vertical axis read the pressure or the atmospheric pressure, and the temperature is on the horizontal axis. So here, this green color line separates the solid phase and the liquid phase. This kind of pinkish, dark pinkish color separate the vapor phase and the liquid phase. Now, on Earth, when the pressure is 1 astronomical unit, 1 ATM. So here the freezing point is where the water phase is coming from liquid phase to solid phase, right? So that is the freezing point. So you see it meets the liquid phase and the solid phase. Then over here, that point is called the boiling point because liquid phase changing into vapor phase. So it's roughly about 100 degrees Celsius, right? So it depends on the pressure though. Now the boiling point on Earth at sea level is 100 degrees Celsius. At Mount Everest, that 5 miles higher than the surface level of Earth, because Mount Everest is 5 miles tall. So its boiling point is 75 degrees Celsius. On Mars, the boiling point is 5 degrees Celsius. So you see, like there's a big difference between the Earth and Mars boiling point, right? So if you look at over here, so on Earth, we can have all the three phases of water. But on Mars, look at the Mars atmospheric pressure. So it's 0.00, about 5.6, right? So over here, at this point, there's no way that water exists as the liquid phase. So on Mars, we can find only the solid phase and the vapor phase. No water phase, the liquid phase of water exist on the on Mars. Okay, but in very limited temperature ranges, we might find some liquid water, but it is really tiny amount, right? So it's depend on the temperature ranges. So the triple point means the where you can see all three phases together. So so the boiling point occurs when the solid, liquid, and gas transitions curves meet. So here, this is the transition of solid to liquid, and this is the transition from liquid to vapor, and those are meeting at this point over here, right? So on Earth, the triple point can be occur somewhere here. So at this point, that is the 32 Fahrenheit, about 32 Fahrenheit, or in Celsius, it's 0.01 Celsius, and the pressure is 0.006 atm. So at 0.006 atm, on Earth, we can see the triple point of water. So that's around 32 Fahrenheit, or the 0.01 Celsius. So that's why I mentioned, like on Mars, there might be liquid water present, but in limited range, like because it's at that corner, right? So if we pass this value a little bit higher pressures, we should be able to see the liquid phase of water as well. But triple point is exist on Earth because we can see all the three phases at one single point. All right, so these are some pictures of taken at Mars. So you see, like there's gullies, like kind of water flows, right? So those are the signs of having liquid water sometime early years on Mars. Then these are kind of narrow riverbeds, right? So these pictures shows us like dried up water flows, right? So these are, we think it is a narrow riverbeds. So about 3 million years old, cut by steady flow of water. And these two pictures of the same crater site taken in 1999 and 2005. A new feature can be seen indicating liquid water flow. So here, this is the picture taken in 2005 and this is the picture taken in 1999. So there's a little difference here because we see some flow of water. So that's the presence of liquid. Again, see this animation show you like how it's changing its flow of water, but it's very, very minimum compared to the Earth percent of water. So March 3rd, March 30th, March 3rd, no water flow, but by May 30th, we can see that little flow of water. So it is thought that the water stays liquid because of heavy concentration of dissolved perchloride salts that lower the freezing point. So that's the quality of this salt, perchloride salt. So the lower freezing point can occur because of the presence of this salt. Then the stakes of flowing water vanishes when the temperature drops, except for these vanishing and occasional spot. It's still true that water on the surface of Mars exists mostly as water vapor and ice. Then little water vapor in the Martian's atmosphere. So as I mentioned, there's water vapor present in the Mars atmosphere. So it can result in making the breaking the ultraviolet light, right? So here, water plus the ultraviolet photon can produce hydrogen and oxygen molecule. So hydrogen escape into the space. So hydrogen can escape. And then this oxygen can bond with the iron in the soil and making the rustiness. So just a little percent of water vapor can create hydrogen and oxygen interacting with the UV proton, ultraviolet photon, and it's break up the water molecule to hydrogen and oxygen. This hydrogen can escape, but oxygen will go bond with the iron, making that rusty look oxide. Then the low density atmosphere, remember like on Mars, the density of atmosphere is low and it results in small greenhouse effect. So it's resulted in large temperature swings. So here, summer on Mars, high temperature is 68 Fahrenheit, the low temperature is negative 243 Fahrenheit. See, like there's a big variation, like even though it is summertime, right? So here on Earth, in the summertime, the temperatures are not varying that much over the day and night, but on Mars, it's really not. It's changing from 68 Fahrenheit to negative 243 Fahrenheit. So it's a big change in the temperatures. So currently the temperature records on Antarctica is high 59 Fahrenheit, low of 129 Fahrenheit. So, so it's kind of same variation as on Mars. So here, the closer to Antarctica, it does have some features like Mars. And this picture shows the clouds on Mars. So Martian clouds are made of ice crystals, frozen water, and frozen carbon dioxide. Then the ice caps on Martian. So these are the pictures taken from Hubble Space Telescope. So Mars North Pole cap. So you see like there's ice, right? So, but also it's kind of melting over here. I mean, melted. But October 1996 is a big ice cap over there. And January 1997, it's a little bit melted. And 1997 March, it's mostly melted out. So ice cap at the north and south poles of Mars are also made of ice, which is frozen water, frozen carbon dioxide. And the thickness is about 1 to 8 kilometers. And the ice caps shrink in summer, grow in winter. So that's the variation you saw here. And Mars has large volcanoes and a huge rift valley, but no plate tectonics. Remember, like on Earth, we do have plate tectonics. But Mars does not have plate tectonics. Two hemispheres of Mars are very different from each other. So the north, mostly smooth plains, south ones are heavily cratered highlands. These are the pictures of topographical map of Mars. So you see like altitudes are changing. The colors represent the altitude. So if you see blue color, that's the low altitude. And if you see kind of reddish, it's kind of mid altitude. And white color means high altitude in kilometers. Again, this is the topographical map of Mars. So you see the variation. So with respect to the colors. And these are the 0 degrees, that's the equator kind of. Then the higher altitudes and the low altitude. And these are the east latitude, right? So 0 degrees and east to west latitudes. So the biggest volcano in the solar system can be found on Mars. That's the Olympus Mons, and about the size of Arizona, 600 kilometers across and rises 27 kilometers above the surrounding plains. The last eruption about 300 million years ago. So it's extinct. And the biggest valley in the solar system also found on Mars, that's Valles Marineris. So it's over 400 kilometers long. That's about the distance from Los Angeles to Boston. So you can imagine like how big it is. 200 kilometer wide and 7 kilometers deep. So the Grand Canyon is 800 kilometer long and 30 kilometers wide, right? So that's the longest valley on Earth, Grand Canyon. It's 800 kilometers long and 30 kilometers wide. A rifty valley caused when the crust was pulled apart. That's the scientists' argument about having this big valley over on the Mars. Then the Mars interior. So astronomers hypothesize that Mars has a core of iron, nickel, and possibly sulfur that extends somewhere between 1200 kilometers and 2400 kilometers from the center of the planet. Because Mars has no magnetic field, astronomers think that the core is probably solid, right? So if you have a liquid inner core, then there should be a magnetic field around that. But here on Mars, there's no magnetic field. That means there's no liquid iron present on the core. So we assume that the Mars interior is solid. All right, let's talk about the humans' presence near Mars in the next video. So please complete the below questions.